Throughout all of recorded human history, mankind has struggled to answer one question. This question, being as prolific as it is, has found its way into every known work of man: art, literature, film. Indeed, this question has perplexed us for many generations, but today, three scientists at the forefront of innovation will attempt to find an answer to the question. Given two constant velocity cars, determine at what position will two cars collide if they are released from opposite ends of a fixed distance at different times. This will be a tough journey for the three scientists, but this is their story.
These are the two cars that we are modeling our predictions off of. This car took about 11 seconds to go 1 meter. This car took about 4 seconds. But of course, the best way to start any good project is with a perfect graph. And that's just what Jaia and I did. At this point, Tyler is graphing the position of the faster car in relation to the graph of the position of the slower one to see where they intersect. Boom. We drew a horizontal dotted line to get the most accurate guess possible. We weren't completely sure where they collided, so we called it a nice round 0.45 meters. And now Tyler is drawing us a beautiful velocity time graph. Because we are treating the cars as if they maintain a perfect constant velocity, the graphs are simply horizontal lines. Now we're going to drop a line down from the intersection on the position time graph to hypothetically see when the cars will collide. Supposedly, the cars will hit each other at about 5.2 seconds. Before we finish up, let's see the math.
To find the point of collision, we can take the velocities of these, in other words, the slope of those two lines, as functions of time and set them equal to each other. But plugging them into the equation y equals mx plus b, we have to add the y-intercept. So plus 1 for the larger truck, seeing as it started at 1 meter, and plus what for 1/4. We need to calculate the y-intercept for 1/4 using y equals mx plus b. In this case, y is 0, m is the slope, so that would be 1/4, times x, which is 3, plus b. Solving for b, we get b equals 3/4. And we can put that in here. Now, simply to solve this and find the point of collision. And here we have the point of collision. Let's see if it checks out with our footage.
To recreate our graph, we released the faster car 3 seconds after the slow car, so that they collided after driving a combined length of 1 meter. And the timing works out.
that our calculations are perfect. There are two reasons I can think of why our numbers aren't spot on with the video. Reason number one is that the cars were not perfectly constant velocity. If they were not, it could cause tiny errors in our calculations. Reason number two is that the cars could also be wavering back and forth, causing them not to travel an exactly perfect straight line, which we also assumed that they were doing in our calculations. Not being a constant velocity and not going in a straight line, those could be the two reasons why our numbers were not exactly perfect.